Welcome to lesson 17. Move the microphone closer. We're going to be playing with Sig Figs and scientific notation. I want to start with scientific notation because I'm sure you've kind of seen this before somewhere. But let's just make sure we all remember exactly what this means. When you see something expressed this way, 1.23 times 10 to the 5th power. Do you remember this trick? The 5 is telling you to slide the decimal 5 places. So if I do that very, very carefully, I'd have to go once, twice. That would get me to a 123. And then to go 5 times, I'd have to go 1, 2, 3 more times, which means you're padding it with zeros, like this. So notice that the decimal used to be right after the 1, but since I moved it to the right 5 places, 1, 2, 3, 4, 5, it ends up over there being a 125,000. Cool. Whoops, whoops. Hey, put that 0 back. Put that 0 back. There we go. So the decimal's not there either. Okay. 123,000. So move the decimal to the right 5 places. Now the reason this works is because if you actually take 10 times 10 times 10 times 10 times 10, well, that's what 10 to the 5th means. It means multiply it by 10 5 times. And actually, you can just look at it that way. Multiply it by 10 5 times. And so you take this 123, you multiply it by 1.23, you multiply it by 10 once, it becomes a 12.3, you multiply it by 10 again, it becomes a 123, you multiply it by 10 again, it becomes a this, you multiply it by 10 again, it becomes like this, and I've done it 1, 2, 3, 4 times, so I have to go again, one more time, put one more 0 on it, and there's our answer, 123,000. So when it says times 10 to the 5th, you know, I never thought of it that way before, but I just thought of it now. You can think of it as multiply by 10 5 times. We all know what multiplying by 10 does. It moves the decimal to the right ones. So do it 5 times, and you'll be golden. Coming down to the next one. Oh, this is a little different because it says -5. It doesn't say 5. It says -5. Well, all negative means is go the other way. You know how the number line starts at 0 and you have positive numbers to the right and negative numbers to the left? That's supposed to be a positive symbol. Same thing. It's like because it's a negative exponent, you're actually sliding the decimal to the left, not to the right. So everything will be the same. So it's like slide the decimal to the left 5 times. Well, if I slide it once, that'll be a 0.456. If I slide it again, it'll be a 0.0456. If I slide it again, it'll be a 0.00456. And if I slide it again, it'll be a 0.000456. And then you just have to keep track of how many times have I slid it. Well, it started here, so that's sliding once, twice, 3 times, 4 times. Looks like I got to go one more time. And so I'll end up with a 0.000456. Okay, so that's working it out the hard way, which unfortunately is also the messy way. So let me like do this way. Didn't we end up with like 4 zeros in front? Yeah. So we used to have a 4.56, but this was telling me to slide the decimal left, negative direction, left, 5 times. That's a once. That's a 2 times. That's a 3 times. That's a 4 times. That's a 5 times. So you end up with a 0.000456, and then you don't really want to leave all this stuff under here, and you certainly don't want to leave the decimal there. No. It's not there anymore. It's over here now. It's over here now. That's where it belongs. Okay. So yeah, it's the old slide the decimal trick. So if it's a positive exponent, you're going to slide it to the right 5 times, and if it's a negative exponent, a -5, you're going to slide it to the left 5 times. Now here's my favorite question. What if it says times 10 to the 0? Ooh. Now which way do you slide it? The easier question to answer would be how far do you slide it? 0 places. 0 places? 0 places. So if you slide it 0 places, then 7.00, if I don't slide the decimal, is 7.00. So this actually is kind of like you don't even need that there, times 10 to the 0. It's just a goofy thing, times 10 to the 0. But, you know, sometimes you'll do it, you'll do calculations, you'll get an answer. It'll say times 10 to the 0. It'll say it right on your calculator, I promise. And then you know that you can basically ignore it because it says don't move the decimal. So, okay, just don't move the decimal and everybody's happy. Theoretically, or maybe I should say more math classy, put this as a PS note, anything to the 0 power equals 1. And if you want to try that on your calculator, be my guest. You can put a 5 in there. If you raise it to the 0 power, it's going to say 1. You can put a 12 in there. If you raise it to the 0 power, it's going to only say 1, and so on. Technically, it doesn't work with 0. You can't go 0 to the 0. But other than that, anything else to the 0 power is equal to 1. Okay, so I don't really need that there either. See, this is the wonder of having one of these things, is I can make my notes look however I want. Okay, so that's how you read the scientific notation. Now let's come over here and put these into scientific notation, like this one over here. I want to make it scientific notation. Well, what you notice all these have in common is they always go number dot number number, and then you have a power. Number dot number number, and then you have a power. Number dot number number, and then you have a power. I'm going to make that an official rule right about here. Number dot number number times 10 to a number. This is scientific notation. Exclamation point. If you ever come across a problem where I'm saying, hey, please express that in scientific notation, it means you will have a number. Oh, by the way, not 0. Don't start with 0 ever. Start with a non-zero number. These can be zeros if you want, but the first one should not be a 0. Not a 0 to start. Okay. So as long as you're not starting with a 0, it's number dot number number times 10 to some other number. So that's what we want to do here. So I'm looking at this, and I'm saying, okay, where do I want the decimal to go? Well, right now, the decimal's over here. That's a no good. We don't want it over there. That's not scientific notation. Scientific notation is supposed to just have one number and then the decimal. One number and then the decimal. We need to put the decimal right there, right after the 5, right between the 5 and the 8. Okay, that's where we want it. So that's the old decimal. This will be the new decimal. Okay, so obviously you cannot simply put the decimal there because 5.87 is, of course, not the same number as 587321896 blah, 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 blah. So you have to sort of give instructions to fix it. You say, well, really, what you would have to do to get back the original number, you would have to take that 5.87, and notice you would certainly have to slide it to the right a whole bunch of times, right? And since you're going to have to slide the decimal to the right a bunch of times, you're going to have a positive exponent, and then you actually have to count to figure out. So I'm going to try to count. I'm going to go, let's see, that's a 1, that's a 2, that's a 3, that's a 4, that's a 5, that's a 6, that's a 7, that's an 8, that's a 9. I'm going to have to go to the right 9 times. 5.87 times 10 to the 9th. Now I didn't mention this, but this is extremely important. When I'm going 5.87, notice that because the next digit was a 3, I rounded down. If that next digit was like a 6 or even a 5, I would actually round up and I would have 5.88 instead of 5.87. It's important to round down. I mean, it's important to round. Round. It's important to round, in this case, round down. All right, now we're looking at this one. We want to make this scientific, and that means I want to have, again, looking at this, I want to have a digit dot and then 2 digits like this. And the first digit should not be a 0. Okay, the first digit should not be a 0. So it's not good enough to move the decimal here, 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 here. I need to not start with the 0. So I'm going to have to put the decimal all the way to there, right in between the 3 and the 7. So I'm going to have a new number that looks like 3.72, and again, we're getting a little lucky. The 1 is telling me to round down, right? So it stays at 3.72. I don't round up to 3.73. 3.72, and then that's not really what the number is, so you have to give instructions on how to fix it, so to speak. And notice to fix it, what we really got to do, to turn this into this, we're going to have to take that decimal and go to the left, which means I'm going to have a negative exponent for sure. Okay, and so the negative exponent's going to be a what now? Well, now you have to count carefully. So let's see now here. I have, there we go. I have to go back 1, 2, 3, 4, 5, 6. Looks like I have to go back 6 places. 3.72 times 10 to the minus 6. There we go. Perfect. Let me check myself real quick. 1, 2, 3, 4, 5, 6. Yes, that would be good. That would be good. Next one. Well, gee whiz, I should have made one of these where you had to round up, but we don't even have to round this one up either. No, we don't. It's going to be a 5.00. Again, start with something that's not a 0, so in this case we can start with the 5. Then put the decimal right after the 5, and then you want to go 2 more places, and then you want to round. So in this case, we're not rounding up, so we just leave it as a 5.00. Then you have to give instructions. The instructions are, hey, you know what? Really, that decimal should go to the right a whole bunch of places. So it's going to be a positive exponent, and then you have to carefully count. Counting 1, 2, 3, 4, 5, 6. 10 to the positive 6. There we go. And then this last one, the main point I want to make with this one, we're going to put the decimal right after the first non-zero digit, which means right after the 9. And we are going to write it this way, 9.00, okay? Because I want everything to be in standard 3-digit scientific notation, okay? So put the zeros, 9.00. So if your calculator says 0.00009, in scientific notation, you would say it's actually 9.00 times 10 to the, and again, to put the decimal back where it belongs, I'd have to go in the negative direction. So it's going to be a negative exponent. And I'd have to move back, count carefully, 1, 2, 3, 4. I'd have to go back 5 places. That decimal would have to slide 5 places. So just make sure you're agreeing with all my answers. If you were to like cover these all up and do them all over again, make sure you would get the same answers again and be happy and all that. Okay, so we got to be able to play with our scientific notation. So that's how you read it, that's how you write it. Boink, 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 boink. I'm trying to boink. Okay. Now we get to Sig Figs, which is in some ways the main topic for today. What are Sig Figs? Well, first of all, that's a sort of a, what do you call it? I was going to say a jive phrase. That's not what I mean. What do I mean? Some kind of a nickname. What the hell do you call it? Anyway, significant figures is what that stands for. Figures means, you know, digits of a number. The figures, 2, 3, 4 are figures. And which ones are significant, which you might say by significant we mean believable. The believable figures. What are they? Well, I think the best way to explain why we have this notion of Sig Figs is to pretend that you just bought one of those maybe Walmart version voltmeters or something. I say Walmart because it's only got 4 digits. So these are like, you know, those LED displays they have where it goes like this and you can make a number that's either a 1 or you can make a 2 or you can make a 3 or whatever. So that's what these are. These are little LED number displays. And right now they're blank because you have the thing turned off. Okay, and then over here, you got probably some kind of a little switchy thing that you can use. It's got like a little thing on it. So you just kind of grab that with your thumb and you can spin it and you can set the, well, you can set the range. You can set the range to say, hey, I'm measuring kilovolts. Or maybe if you clicked it over here, you'd be measuring volts. Or if you clicked it over here, you'd be measuring megavolts. We're going to learn these prefixes actually next time. That's a capital M, by the way. Megavolts, kilovolts, volts, whatever. And so since you have this knobby sort of lined up with kilovolts, right now it's going to measure kilovolts. And so then you take your meter, let's say this is your meter, this big old meter there, and it's going to have some wires on it. You know, you're going to hitch the wires up to something, and you're going to measure, hey, what's my voltage? So what I was trying to draw there, maybe I'll draw it just a little bit better, is imagine you have some kind of there's a circuit and there's a resistor, and this of course hitches up to all kinds of stuff. And what you're doing is you're taking your wires and you're putting one probe there and you're putting the other probe there. And what it'll do is it'll tell you how many volts do you have from here to here. Voltage is like pressure. So when you blow through a straw, you have a high pressure in your mouth and a low pressure outside your mouth. Well, electricity is kind of the same thing. If the electricity is flowing this way, that's because you have a high pressure or a high voltage here and a low pressure or a low voltage here. So if you put your voltage prongs here and here, you're going to say, well, that's high, that's low, and it'll tell you how different it is. Like pressure gauges, they always measure a pressure drop. They don't necessarily tell you absolute pressure. They usually tell you, hey, you just lost so much. I take that back. You can measure absolute pressure. But voltage, you're measuring a change. Okay. So, here's the question. Let's say you hitch up this meter and it says 0, 0, 0, 1. Like this. Let's say your meter says that. This, I think, wait, what are you doing to me? What are you doing to me? Go. Hey, you. Okay. It says it's a touch screen, but sometimes you have to really touch. Anyway, so I got this 0001. I think you'll agree with me that this is one significant figure. And you might think of it as one measured digit. Only one of these digits is actually measured. The reason these are zeros is because you don't have enough of a signal to trigger that. It's just maybe the things, maybe it's wavering a little bit. Maybe this is going 0, 1, 2, 1, 2, 1, 0, 1. You can picture sometimes the meters will fluctuate a little bit. So this one's going 1, 0, 0, 2, 1, 1, whatever. This one's fluctuating, so there's something happening here, right? So you're getting a reading there. That's a measured digit. But these are just sitting here not doing nothing, and that's because there's not enough juice to move them. They're not measured. They're not there. They're not significant figures. Okay. I like being able to clean up my messes. This is great. Now, what if it said, what if you measured it and it said this, 0, 0, 1, 2? How many of those look measured to you? Well, you got to say 2 Sig Figs, don't you? Because it's the 1 and the 2. This time you've got enough signal that something's registering here and something's registering here. It's been able to push it off the 0, which means, well, it's a measured digit. This is still not measured. You weren't even able to push it off the 0. So that's 2 Sig Figs. 2 measured digits. Now here's where it gets a little tricky. Look at this next example here. 0.0120, so I'm going to have to change this. 0.0120, and there's a decimal here. As you spin this thing around, the decimal moves back and forth is what tends to happen. But let's say that it happens to be that the decimal is right there. 0.0120. How many of those digits are measured? See if you can figure this out. I usually get all kinds of answers when I do this in class. It turns out the correct answer is 3 Sig Figs. And here's how you make sense of that. This looks like a 0.0120, right? So it could be maybe that it's a 121, or it could even be a 119. It could be bouncing up and down. This has been pushed off the 0. Why do I say that? It's been pushed off the 0 in order to turn that into a 2. You have to have signal here if you have signal here. This is like 2, and then this is like, smaller measure, smaller. This is in the thousandths place. This is in the 10,000ths place. Well, you can't measure the thousandths if you don't detect some 10,000ths as well, So anything to the right, even if it's a 0, that counts. And the 1 obviously counts. And then this does not count. Even though you have the decimal here, and it makes it look like, well, the number starts at the decimal, right? It's like, yeah, the number starts at the decimal, but the measurement doesn't start at the decimal. You are not able to get this to move off the 0. It's just slumbering. There's nothing there. You've only got the 3 sig figs. So the moral of this story is, if you like rules, I hate rules. I hate rules. But so many people love them, so whatever. But if you wanted a rule, it would be something to the effect of don't count any initial zeros, even if they're after a decimal. Okay, you don't count those. You don't count that as a sig fig. So it's actually 0.0 doesn't count, but then the 1 counts, and the 2 counts, and because the 1 and the 2 count, if you had more zeros, they'd also count. Okay, anything to the right counts, but nothing to the left counts. Because you do not have these zeros actually here, it means you do not have it set up to actually register anything over there. So you would not count those as sig figs. Okay, they have to be there to count. They actually have to be on your measurement device to count. But if you have a 0 on your measurement device right there, that counts. You have a 2, it counts. You have a 1, it counts. If you have a 0 here, that does not count because it's an initial 0. It's a leading 0. It doesn't count yet. That 0 has not been moved by any signal. It's nope, nope, nope. So we end this little section by asking you, hey, how many sig figs we got there? That's a question mark. How many sig figs we got there? And the answer is, hopefully you're getting this, 4. 4 sig figs. You start counting right there at the first non-zero. So that counts. Any zeros on your machine that follow will count. So that counts, that counts, that counts. So it counts all the way over. 4 sig figs. Okay, so you're looking for the first non-zero, and then you're counting everything after that. That's actually measured, of course. You can't just add your own zeros. But if you've got zeros showing up on your meter, fine, they count. If they come after, who invented these iPads? Okay, so anyway, they go like that. That counts. Yes. This counts. No. Okay, so that's what sig figs are. And again, I always think of, I say believable because another way to think of them is they're measured. They were measured numbers, and that's why you can believe them. Okay. Sig figs in action. Okay, there's 2 main reasons we worry about sig figs, and one is, well, you really have to worry about them now that we have these electronic calculators all over the place. Because how often do you ask a calculator a question and it says, well, like this one, watch this, watch this. We're going to take Biff, he's going to get some gas, and he's going to drive. So actually, first he drives, he fills up his tank, right? And then he notices that he goes 114.8 miles because that's what his odometer looks, he has a little trip tick and it says, hey, you just went 114.8 miles. And he goes back to the gas pump, gets gas. And I believe the gas meters, don't they go out to 3 decimal places? I'm not sure how accurate they are, but let's just say they go out to 3 decimal places. So what's his miles per gallon? MPG, miles per gallon. Miles per gallon means you would take the number of miles divided by the number of gallons. Okay, so if you went 10 miles on 1 gallon, that would be 10 miles per gallon. If you went 10 miles on 2 gallon, that would only be 5 miles per gallon, and so on, right? So that's why the division makes sense. So what have we got? We've got 114.8 miles on top, and we've got 8.401 gallons on the bottom. And that means that you should get out your calculator and divide. And so I'm going to do that now. Hey, watch this. My camera there. Oh, what's happening? Oh, wow. Guess the problem, guys. Okay, so here we go. Turn on the calculator. Boink. Casio, ready to go. What the heck was I doing? Ah, dang. I have to go back. 114.8 divided by 8.401. 114.8 divided by, I want to say it was 8.401, right? 8.401. Yeah, I'm pretty sure that was it. So you do this nice little innocent calculation on your calculator, and then you hit your equals to see what you get. And how often have you seen this happen, right? The calculator says, you know what, it's 13.66503.988. That's what it is. So the calculator is telling us 13.66503.988 miles per gallon. Now, if you put that answer down and you circle that, you're going to lose points. Let's just put a big no. Why? Well, did you get this number from like a meter? A meter that read the accuracy all the way out to 8 decimal places? Like you actually measured a 1, a 3, a 6, a 6, a 5, a 0, a 3, a 9, an 8, an 8. Those are not all measured. Not all measured numbers. This number is deceivingly accurate looking. You don't know your mileage this well. How well do you know it? Where was I? I think I can work that out. What was I saying? Oh yeah, that's deceivingly accurate looking. It's a no good. So how accurate should it be? Well, you can look over these numbers and you can say, well, this number, now that was measured, right? You look at your odometer, you can get, 4 Sig Figs like that. You can read to the nearest tenth of a mile. And then on the pump, you can read 4 Sig Figs. Pretty sure they go out to 3 decimal places. Okay. Pretty sure. So anyway, you can get 4 Sig Figs. So notice that we've got here 4 Sig Figs to start. The idea is if you started with 4 measured numbers, you're not going to end with 10 measured numbers. You're going to end with 4 measured numbers. And so really, we should think about rounding this off at 4 digits. Now I do say round. This 5 is telling me to round that up. 13.67 miles per gallon. That is as accurate as you can claim. You can claim it out to 13.67. Okay? You cannot say the answer is 3.66503.988. That's ridiculous. These numbers are actually meaningless because they couldn't the only way those numbers could be meaningful is if this happened to be a 114.800000000 and this was an 8.401000000 and you really did measure all those then you could say the answer was that accurate, but it's not. It's not. You had 4 digits to begin, you have 4 digits to end. That's the basic idea. So, from now on, when you write answers to questions, I need you to be mindful of the Sig Figs. Never use more than you started with. And on the other hand, you don't want to use fewer either. You wouldn't want to just say, oh, I'm getting 14. Because you have more than 2 Sig Figs here. So you don't want to lose any accuracy either. You want to keep the accuracy. You want to express the accuracy of the measurements. And by the way, if one of these was 3 and one of these was 4, you'd use 3. You have to go with the least accurate number. I'm going to put that on the quiz. Hey, make sure you note that. Were you listening to this part of the video? Because I'm going to put that on the quiz. I'm going to say, hey, what if one number has 3 Sig Figs and the other has 4? What do you round your answer to? And the answer is 3. You go with the least accurate number. It'd be interesting to see how many people get that right. Hopefully all of you. Anyway, example 2. Bonnie hitches up her new nifty voltmeter and she measures 120 kilovolts. Okay, let's have Bonnie do that. She measures, and let's assume that, that this is all measured. Let's assume it's 3 Sig Figs. I'm going to assume that that's a measured 0. So she has 3 Sig Figs of accuracy, right? And those are, it says here, kilovolts. So that would actually have units of kilovolts. 120 kilovolts, which is 3 Sig Figs. The question says, hey, convert to volts. Okay. Well, it turns out kilovolt is 1,000 volts. So instead of saying 120 kilovolt, you can say 120,000 volts, because kilo means 1,000. And that means, of course, that it's 120,000. Let me write this a little bit more neatly. that it's a 120,000 volts. Now that's the correct conversion. 120 kilovolts is 120,000 volts. Do you see a problem here? Problem is, that looks like maybe 6 sig figs. If you write down 1, 2, 0, 0, 0, 0, doesn't that look like 6 sig figs? But it's not. It's supposed to be 3. It's supposed to be 3. So when you write down the 120,000 volts, how do you communicate to somebody, hey, this is only 3 sig figs? And I saw this book once that said, hey, I know what you do. You put a bar over that 0 to say that's the last of the significant zeros. And so that says, yeah, that's 3 sig figs. So if you wanted to, we could learn a lot of rules. I used to try to teach the rules. There's rules that you can use for sig figs. When do you count the 0 and when do you count? Like sometimes they say you can put a 120 point and that makes the 0 count. But if they don't put the point, then the 0 doesn't count. Or you could, of course, put the bar over it and then it counts again, and so on. So there's these rules, and then there's these rounding rules and all this stuff. And I used to teach that, but I found that it's hard to use that. It's hard to use the rules consistently because you end up with these weird things happening. So I don't like using the rules. So what we're going to do is we're going to do sig figs without rules. Sounds good, doesn't it? Sig figs without rules. And, well, there is a rule, of course. The rule is to use scientific notation with 3 sig figs. Just if you always use scientific notation with 3 sig figs, then the sig figs will take care of themselves. I stole this rule from actually Anoka Tech. They use 4, but I'm like, 3's plenty for us. So up at Anoka Tech, they say, just use 4. Just always use 4 sig figs, no matter what, always. And so I'm going to say, we'll use 3. Just always use 3 sig figs, no matter what, always, and life will be fine. Life will be fine. We'll get along just fine. Okay. Yeah, we'll get along just fine. Yeah, the grader. You and the grader will get along fine. How's that sound? Of course, I'm the grader. Anyway, so how do we do this? Well, we want to set the calculators to stun, which means I have to look at the calculator. I have to look at the calculator now. Let's call up the calculator. If you want scientific notation, you might remember this from, I think it was the last lecture, wasn't it? You go to Shift, little S shows up, Shift. Setup. Scientific notation is option 7 here. So you press the 7. That's what you do. You press the 7. Okay. And then it asks you a question. It says, okay, you want scientific, but 0 to 9. Now the 0 to 9 is the sig figs. I don't know why you'd want 0 sig figs. That sounds weird. Anyway, but you can go up to 9. And we want 3 sig figs. And so I'm going to press the 3. Why would you want 0 sig figs? I'm going to have to look at that someday. Anyway, 3. 3 sig figs. And look what it did. It took our answer, whatever it was, and it converted it into 3 sig figs. Scientific notation. 1.37 times 10 to the 1. And remember, 10 to the 1 means slide the decimal to the right once. So this is another way of saying 13.7. So that was this example up here, by the way, where I said the best answer was 13.67. But, if we agree to just use 3 sig figs all the time, then 13.7 is like, yay, the world's happy enough. Okay, so let's put a little reminder here. How did I get into scientific notation? I went Shift, Setup, 7, and then a 3. That would be scientific notation with 3 sig figs. And by the way, I might as well just put this right here to get back to normal. You could use a Shift, Setup, 8, 1. That's how I get back to normal. To get to normal. Yeah, to get back to normal. That says get. Anyway, shift setup 3 gets us into the scientific notation, and that's what you should do for your homework. For at least a couple of lectures, you should have your calculator in this scientific notation with 3 sig figs, shift setup 7-3, and life will be good. Now we come to the main event. How do you do math with scientific notation using this calculator and all kinds of stuff? So I've got 3 formulas here. These are electrical formulas. These are real things that you're going to have to deal with. So let's show you how you use the calculator to do all these things. Okay, watch this. So see this? E equals square root of P times R. And we're being asked to substitute in P equals this scientific notation. R equals this scientific notation. So let me make sure I've got these things in front of me. Okay, before I go back to the computer. Okay, so what we're going to do, back to the calculator. Get your calculator out. Watch this. First of all, I'm going to hit the AC to clear all this stuff. Okay. Now it says square root of PR. So the big thing happening is square root. So I'm going to hit the square root. Boom. And then notice the PR are multiplied together. Now when I'm playing with Sig Fig, or when I'm playing with scientific notation, I like to use my parentheses to indicate a multiplication. Remember, if 2 things are bumping up against each other with parentheses, that means multiplication. So I'm going to open up a parentheses, and I'm supposed to put the power in, and the power was 3.62 times 10 to the 3. So here's how you can do that. You can go 3.62. Are you ready for this? This is the big thing. How do you do the times 10 to the 3? The easiest way is right there, that button at the bottom center, times 10 to a power. That's the button. That's the star of the show in many ways. You hit that button, boink, and notice it sets up a times 10, and it wants you to put a number in which will represent the exponent. So it's supposed to be an exponent of 3. So that's how you enter 3.62 times 10 to the 3. You don't have to say times 10 raised to a power 3. You can, but you're wasting your time. You just go times 10 to the 3, and then it's entered. That's my power. Close the parentheses because I'm done entering that number. Open a parentheses, and again, 2 parentheses against each other means it's going to multiply these things. And the next number was the resistance, R, which was 4.71. So I'm going to enter 4.71. It's hard to do left-handed. 4.71, and it's times 10 to the 7th power. So again, here's your scientific notation button right there. Times 10 to the 7th. You just go boom, boom. 2 buttons times 10 to the 7. Right? This is the button you want to use. Okay, and then I'm going to close this, and then I'm going to hit equals. And because I have it in scientific notation mode, it gives me the answer with 3 sig figs in scientific notation. Bada boom, bada bing, we're done. We did it. So let's go back and write that down. So again, what did I do? I hit the square root button, and then I opened up a parentheses, and then my power I entered by going 3.62. I used my times 10 to the x button. That's the big button. And then the 3. And then I closed the parentheses, and then I opened up a new parentheses, and then I hit the 4.71, and then I used the times 10 to the x button, and then I put a 7 in, and then I closed the parentheses, and then I hit equals. And it gave me the answer as 4.13 times 10 to the 5th. Woohoo, woohoo, woohoo. Isn't that sweet? I think that's so sweet. It just works. How sweet can you get? You want to maybe try that one yourself? And then come back? Back already? Okay. So what we're going to do then, let's go back to my, let's see, I got to remember this. Okay, you've got it in front of you, but I got to remember this. Because you go like this. Go back to the camera. Boink, boink. And I'm going to hit the all clear. All clear. And let's see, it's a fraction, right? So the overall effect is you have a fraction. So I'm going to use that fraction button. We saw that. And it's nothing but a 1 on top, so I can put the 1 right in there, right? The cursor starts on top, so I put the 1 in. Hit the down arrow to come downstairs. Now, 2 pi fc. So 2 is here. Pi. You see that times 10 to the x button? You see the yellow ink pi above it? That means you can go shift here, And then you've got a pi. And by the way, it knows 2 pi means 2 times pi. It knows that. I like that too. And the nice thing too is you've got pi to like 15 decimal places of accuracy, right? What could be better? So you've got 2 times a very accurate pi. Now I want to keep multiplying. Now, unfortunately, if I want to keep multiplying, I have to start opening up parentheses so that it knows that I mean to multiply. It's happy with a number in front of pi, 2 pi, it knows. But you can't say pi 2. It'll go, what? So if you're going to multiply something, pi times something, you have to use parentheses. What was I supposed to put in there? An F, which was only a 60, just a plain old 60. That stands for 60 hertz. North American frequency of AC electricity is 60 hertz, 60 cycles per second. Anyway, and then times the capacitance, C. So you hit this, open this up. And it says it's 1.50 times 10 to the negative 6. Okay? 1.50. This is your times 10 to the button. Times 10 to the. Now it's a negative 6. So I have to show something here too. Make sure if you want a negative exponent, you're not using this key. That's a subtraction key, which is actually different from this key, which is the negative number key. So you want a negative exponent, you have to use the negative key. Trust me, you have to, unless you want your calculator to freak out, and then you to freak out. You use this to enter negative numbers, especially negative exponent. Well, any negative number, use this. So anyway, it was 1.50 times 10 to the negative 6. There we are. And I like to close my parentheses just to be official. And that's it, right? So I can just hit equals. And bada boom, bada bing, there's the answer. 3 Sig Figs, scientific notation, all rounded properly, all nice, nice. Wonderful, wonderful. So let's go back. What did I do here? I did a fraction button, right? I put the 1 in, then I hit the down arrow, I hit the 2, and then I used a shift to get pi. So that's really 2 buttons, but I'll write it as 1. Shift pi, and then I had to open up this to keep multiplying things. I put the 60 in, I closed it, I opened it. That's the parentheses I'm opening. I put in the 1.50. I used the times 10 to the X button. Then I had to use that special negative key, and that's what it looks like on the key. It's like a negative in parentheses. It means I'm making it a negative, and then I can put the 6 in, then I can close the parentheses, then I can hit the equals. So that's your button order pushing thing. And you push all those buttons in, like I say, it just spits it right out. 1.77 times 10 to the third. That is your answer. Okay, well, if you didn't accept that challenge, then you really ought to accept this challenge. Try to put that puppy in. Evaluate that one. See what you get. Okay, if I got this written down, good. And away we go. Camera time, boink. Calculator time, boink. Okay, let's hit the all clear. That's a mess. Okay. Well, once more, we've got a fraction overall. So I'll hit the fraction key. Notice the cursor is blinking on top. So I can put the 1 there. I can put the 1 there. Then I can hit the down arrow, come down to the bottom. Now the whole denominator is in a big old square root. So I'm going to hit the square root. First thing I come across is a parentheses being squared. So I'm going to open up a parentheses. In the parentheses is a fraction. So I'm hitting the fraction again. I just love this whole pretty print thing, so you can really keep track that you're entering the formula the way you think you're entering the formula, you know. Yeah, something like that. So 1 over r is what we got in there. So I hit the 1, come down. Now I have to type in the r, and the r is 2.14. Here's the scientific notation button. Times 10 to the 5th. Okay. Now the cursor is still in the denominator. You don't want that. You don't want to close the parentheses now, because then look how weird that is, right? So you have to, again, I hit my DEL to go back 1. I have to hit the right arrow to get out of the denominator. Then I can close the parentheses. Now it looks good. And that's supposed to be squared as a shortcut for squaring things, the little x squared button. Boink. Cool. Then I can say plus, plus. Then I can open up the parentheses. Boom. There's another fraction inside this parentheses. Boom. And this has a 1 on top again. 1. Down arrow to get to the bottom. Boom. And what do I got here? 3.61 times 10 to the 4th. So 3.61 times 10 to the 4th. And again, I want to square this, but I need to get the cursor out. So I have to hit the right arrow, get the cursor out of the denominator. Now I can close it. Then I can square it. And now I'm good. I can hit equals. And just like that, 3 Sig Figs, scientific notation, 3.56 times 10 to the 4th. Cool beans. So what do we do here? We hit the fraction button. We put the 1 on top. We put the arrow. We put the square root button. We did an open parenthesis. We put the 1. Then we came down and we put the r, which is 2.14. And then we used the times 10 to the x button. And then we hit the 5. And then I had to hit the right arrow to get out of the denominator, remember? And then close the parentheses. And then I used the x squared button. That was fun. And then I used the plus button. And then I used the parentheses again. And then I used the fraction button again. You put the 1 on top again, come down. And I had to enter the x sub c, so I guess I'll do that like right about here. I had to enter the 3.61 times 10 to the x button. And then the 4. And then I had to hit the right arrow to get out of the denominator so I could close the parentheses so that I could square the parentheses using the square button. Then I was able to hit equals. And the answer we got, 3.56 times 10 to the 4th. There we go. So this is another of the nice little secret powers that this calculator has. It handles the scientific notation extremely easily, I think. Everything you need is, whoops, what I do? Hey, how, hi, hey, ho. Everything you need is do. It's right there. You get your times 10 to the x button right there. You get your negative button right there. You can get your square roots. You get your fraction buttons. You got all kinds of stuff. Square buttons. You can raise it to other powers, of course. It's all right there. You don't have to use menus. That's the fun with those graphing calculators. Often you can do fractions, but first you have to go like math menu, fraction menu, and then you have to scroll down a few places and say, yeah, I really want to enter a fraction. Can I do it now? And then, you know, those things are not so fun. This one's fun. This is the fun calculator. If you got it yet, you should get it. It's cool. Like I said,